Okay, now to make sure the titration's done, we're going to overshoot it. And instead of the 100 at equivalents, we're going to add 105 milliliters of NaOH. Really what this means is we're just adding 5 extra, but again, we need to look at it like we did this whole problem right from the start. I would say to myself, looking at this, what this means is I added 5 mLs of NaOH too much. Meaning 100 of those 105 milliliters are going to react and they're going to turn into the nitrite ion and water, and then they're going to go through salt hydrolysis and blah, 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 blah. But 5 milliliters are going to do nothing but dissolve, meaning 5 milliliters are going to turn into pure OH ions. That's going to make the OH concentration so much greater than anything else that takes place. So I'm going to calculate the pH just from those extra 5 milliliters, and then I'll do it with taking into consideration all the OHs in solution. And we'll see, it doesn't change the pH by a ton. This would not be the most accurate way to do it, but it would be sufficient because that's a strong base, and the strong base is going to have a way larger impact on the pH than a weak base, the NO2 ion, that's in solution. So I'm going to say that I have 0.005 liters times 0.50 molar, and that's going to be 0.0025 moles. Now I had to turn it to moles because to get the pOH, I have to get OH minus concentration. So if I have this many moles of OH minus, well, in how many liters now? I've added 100 milliliters to 105 milliliters, so this is in 0.205 liters. Or in other words, OH minus concentration is equal to, whatever that value turns out to be, 0.012 molar. Pretty high concentration, only 10, so we should expect a pOH somewhere near 1. So pOH on this turns out to be 1.91, or pH at this point is going to be 12.09. All of a sudden now it's insanely basic, a huge jump just from that extra 5 milliliters. We watched the level of OH go up because those extra 5 completely dissolved. Now, if we want to take the other guys into consideration, we definitely can, because in our last problem, in this guy right here, at the equivalence point, we realized that we had salt hydrolysis and some OH ions were made. So let's take those into account and see how it changes our answer. Plus water makes in equilibrium HNO2 plus OH minus. And again, we know the Kb from him from the last problem is 2.2 times 10 to the minus 11. So I have the same value of him, 0.25 molar, starting out. I have that same value, but now I have actually changed the concentration because I've added more solution. So I'm going to go back to my actual number of moles I have of NO2. At this point, I would have had 0.050 moles of NO2, and I'm going to do that problem with 0.050 moles of him. And I was having from that problem if we go back, doing all my X work, I knew exactly what those values were. So I could say for this guy, how much OH was he going to create? How much OH was made? And I went back from this problem and figured out that he made 0.24 times 10 to the minus 6 molarity of OH ions. So if I go back to this problem, 2.4 times 10 to the minus 6 molar in 200 milliliters. Well, or 0.200 liters. Well, if I took that many moles per liter, 0.24 times 0.20 liters, I have to actually do that. I haven't done that one on my calculator. 2.4 second E minus 6 times 0.2, I would get an answer of 4.8 times 10 to the minus 7 moles of OH minus formed from this reaction. But I still have that extra 5 milliliters that I added. So I'd have to add that to the amount from my extra, which if I go back, it was 0.01 or 0.0025 moles extra. So I would add this value to 0.0025 moles extra. And if I did that math, plus 0.0025, I get an answer of 0.00250048. Or in other words, adding that didn't make any difference. Only the extra OH ion mattered. So why worry about accounting for the OH that's formed from here? Because it's an insignificant amount, a very tiny amount. It's this amount right there. That was a terrible circle I just circled it with. But it was that amount right there. It's so tiny compared to the 0.0025 moles just from the 5 extra milliliters that it doesn't make a difference.